Hello, my name is Stanley Uskolski. I've been in the moisture investigation field and indoor air quality field for the past 9 years. We're going to cover some basic investigation techniques in this video, as well as EPA remediation guidelines. We're going to show you some common areas to look for mold in the average home. We're going to start here in the kitchen. There are a few areas in the kitchen that historically have had problems with mold growth. We're going to start at the refrigerator, looking behind and below it because of the ice maker and the coils. Take the flashlight and shine it behind the refrigerator and shadow the walls. Look for any signs of moisture, leakage, or mold growth. You can take off the front grill or look below it when it's accessible. Under a refrigerator, you have elevated temperatures. Much dust collects under the refrigerator, and this provides a food source for any mold. If elevated moisture becomes present, you have favorable conditions for mold growth. If you have wood floors under a refrigerator or adjacent to it, then this becomes even a more important issue. Sinks are another important area to inspect. You can have water dripping from above, you can have water coming from below at the supply lines and the waste lines. All sinks should be given a lot of attention in your investigation. With the water running, we're going to look for leaks around the sink and below the sink at the drain basket and around the faucet. With the cabinet open, we're looking for leaks around the supply lines and the waste line. Shadow the areas with your flashlight. Also, look for any water damage on the inside base of the cabinet. Another area to look for moisture damage is in front of the dishwasher on the floor. This could be a result from a leak around the door itself or at the supply line or drain line under the dishwasher. I do this by tapping the floor and listening for a hollow sound under the floor. This could be an indicator of water-related damage to the subfloor. During the inspection, I take my flashlight and I look on the floor around the dishwasher and underneath of it. You also may want to take the front plate off and look under the dishwasher for any signs of moisture damage or leakage. While we're in the kitchen, we want to look at another common area for leaks, and that are these skylights. We're looking for any signs of water infiltration, stains around the skylights, bubbling or sagging in the paint around it, drywall damage, or visible mold growth. Use your flashlight to shadow the walls and look around the skylights. Common areas to look for leaks around the toilet are at the base of the toilet itself and the supply line and the tank. Want to look at the tub as well. Want to look around the wall for any signs of water damage. Want to look around the fixtures. Want to tap on the wall. And if at all possible, you want to get below the tub and look at the waste lines as well as the supply line. Also, you want to look at the floor around the toilet and adjacent tub for any signs of water-related damage. One of the problems in hot, humid climates is condensation, especially around HVAC supply vents. If this isn't corrected and humidity levels aren't dropped, then it creates a favorable condition for mold to grow on the vent as well as around the vent on the surrounding drywall or materials. Mold growth on a metal vent is not on the metal itself, but on the dust and debris that accumulates on the metal. The vent should be kept dry and clean. Since the air handler is distributing air around the house, this is a good area to look for mold growth. We want to look at the air handler coils, the filter, the blower unit, and the adjacent walls around the unit. The air handler on cooling mode can have a lot of condensation around it, and therefore a lot of moisture. A unit that is not properly maintained and serviced can allow the condensate drain to clog up, and this will back up around the unit and create favorable conditions for mold growth. With regards to mold abatement, if you're not running the air conditioner, you need to go ahead and get a dehumidifier to pull the moisture out of the air. If you are running it when you have mold growth or contamination, then you have to also clean the unit and the ducts to go ahead and remove any mold spores that have contaminated. Some ducts cannot be cleaned, such as what we have here. This is a fiberglass lined duct. You cannot clean it, and you'd create more damage if you tried to clean that. During your investigation, the blower unit and the coils are a good location to take a swab sample. The water heater is another appliance that you need to inspect. You have to look around the supply lines, the temperature relief valve, and the base of the unit for any signs of moisture. While we're down here, we're going to look for any signs of leaks around the base and the drain itself. And here we have a catch pan, and this is a good addition for a water heater, a washer, or a water conditioner. The overflow pan should have a drainette and go to a proper point of termination. We're in a house that had a water event. It was a tidal surge, and during the investigation of this house, it's better to err on the side of caution and be careful. So I'm going to wear an N95 respirator. The key concept to controlling mold growth is moisture. That's the easiest thing we have to control. Mold needs three conditions to grow: the right amount of moisture, organic materials, which is a food source, and the right environmental conditions, temperature, humidity. The easiest thing for us to control is moisture. Food is available everywhere, and environmental conditions that are favorable for us to live in and comfortable are favorable for mold growth. There are two other concepts I'd like to review as well. That is, the concept of mold can be viable and non-viable. Viable means that mold is capable of growing under favorable conditions, and we mentioned those earlier. One of the key favorable conditions is proper moisture content for mold growth. And non-viable means that the mold is not able to grow under favorable conditions. It's essentially dead. Mold can be dormant as well, and that's why we talk about viable. It can go dormant when moisture levels drop, and then if the moisture levels rise through an act of moisture intrusion, an act of leak, or from proper humidity, the mold can start growing again. Viable and non-viable molds, molds that are living and dead, can cause allergic reactions. This is generally accepted in the medical community. The health effects associated with mold are allergenic, pathogenic, and toxigenic. Allergenic effects associated with mold are things we commonly think of as hay fever symptoms, runny nose, itchy eyes, dermatitis, which would be a rash or skin itchiness, coughing, wheezing, as well as it exacerbates asthma, often triggering asthma attacks in susceptible individuals. That's most common side effects from mold exposure. And even if you do not have a sensitivity to mold, constant exposure, or a severe exposure can trigger an allergenic reaction. Pathogenic health effects are from an infectious agent, and that would be the mold actually grows in or on you. And the most common types that we think of are aspergillosis, an infection in your lungs from mold, fungi. Often this can occur in immune-compromised or people that are sick, weakened individuals. And this can be somebody who's just had a hospital stay. It does not have to be somebody who has a severe illness. The other health effect from mold exposure is toxigenic, and that's where you react to the mycotoxins produced by mold. The health effects from that are neurological, central nervous system, blood, pulmonary, and carcinogenic, causing cancer. Having talked about the health effects of mold exposure, each individual will react differently. It's a subjective reaction to the mold. For example, many people have hay fever, but not everybody has hay fever. Some people react to bee stings, other people don't. Or, how many times do you go to the doctor and they say, do you have any allergies to medication? For example, penicillin. Penicillin is made from mold, penicillium. It's important to keep in mind this subjective reaction because not every person will have the same degree of problems from exposure. And the more you're exposed to it, the more potential there is to have a reaction. That is why it's important when doing investigations or when doing repairs and remediation to realize that even if the mold has become dormant or has died, it still can have a health effect on you. Now that I've explained the health effects from mold exposure, I'd like to go into some investigative techniques. One of the first things that you want to do is use your senses. You want to look for signs of mold, you want to look for signs of water damage or water intrusion. You also want to use your sense of smell. A lot of times you'll have a musty smell, a fruity, a locker room, earthy smell that will indicate there's been mold growth. Sometimes there is no smell though, but you'll react physically to it. Your throat might become raspy, close up. You may have itchy eyes, watery eyes. You might start sneezing. Some people even have an asthmatic attack when they walk into a place that's had mold growth. Some of the common water events may be due to rain, roof leaks, plumbing leaks, condensation from HVAC, air handlers, tidal surges, and that's what we have here, where the ocean seawater actually came into the house, or it could be freshwater events from overflow ponds or lakes during heavy rains or rivers. There's a misconception that salt water will not allow mold growth or will inhibit it, and that really is not true, because once the salt water has left, it's left behind water that's going to create very hot, humid conditions, and that's going to create a potential for mold growth as well as a favorable environment for mold. Here we have a wall that got flooded from saltwater intrusion, a tidal surge, and even though the water may only come up to here, the moisture will travel up higher and also create a very humid condition inside the wall. So you can have very wet conditions higher up than the actual water level of the seawater coming in. The moisture can travel up through wicking, into the sill plate here, into the framing, into the drywall, into this felt layer, up here, and in the insulation as well. And that moisture can go up very high, and it will keep traveling so long as it's wet. So if it's wet in here, the moisture can go all the way to the ceiling. It's extremely important to remove the moisture within 24 to 48 hours of any water event. These walls have been opened to evaluate the problem inside, the amount of moisture, and to facilitate the drying, so the walls can dry out. I use a temperature and humidity sensor to measure the temperature and relative humidity inside and outside. This place has a musty odor and visible signs of mold growth. The temperature in here is 79 degrees. The relative humidity is 70%. These conditions are favorable for mold growth. And the dew point in this house is at 70 degrees. So condensation can start occurring above 70 degrees on the surfaces of this house. Temperature and humidity can vary around the room or even a building, so you want to take multiple readings. During an investigation, we're looking for visible mold growth. These would be irregular patterns, discoloration, fuzzy, blemished areas, the water staining that may be mold growth that's not visible. It's important when looking for visible mold growth to not just focus in on black mold or a particular color. Molds can come in all types of colors, from gray, whitish to black. And even the same species of mold can have different colors at different times during their life cycles or depending on the materials they grow on. Black mold is what we've heard about a lot in the media. And specifically, they're talking about the genus of Stachybotrys. But there are other molds that are just as dangerous and cause more health effects and more known health effects. When a flood occurs, one of the common areas for moisture to become trapped is below the base cabinets in the kitchen and bath behind the toe kickboard. This is why it's essential for these to be removed to facilitate drying and to evaluate the area. Other areas to look for mold growth are behind refrigerators, behind washer and dryers, crawl spaces, air handlers, at the coils, at the filter. Other areas that may be suspect for mold growth are behind wall coverings such as vinyl or foil wallpaper, or below floor coverings such as carpet and hardwood flooring, or behind pictures and mirrors on the wall. Here we have an in-wall package unit, air conditioning, and this area right here at the supply is suspect for mold. It's probably due to the condensation occurring on the plastic, and the mold growth is on dust particles and just organic materials that settle on the plastic. This would be an area that you'd take a surface sample. If this is mold, the spores can be dissipated, or the fragments of the mold can be dissipated throughout the house. A common problem is air conditioning. It's not just the lack of air conditioning that can create high humidity and favorable conditions for mold growth. It's also oversizing the units for a house or a building. And this is because the air conditioning needs to run long enough to remove the moisture from the air. If the unit is oversized, it does what's called short cycling, and it comes on and goes off so quickly that it doesn't have a chance to remove the moisture from the air. It simply cools the air. The second benefit of air conditioning is as a dehumidifier, and that's very important because we need to keep the moisture in the air below 60% relative humidity. Mold is capable of growing anything above 70% relative humidity. That's why it's important in these situations to have proper cleanup. And one of the most important things about proper cleanup is fixing the source of the moisture. fix any leaking plumbing, fix any humidity problems, fix any HVAC problems that are creating high humidity conditions. If you do not fix the source, the mold growth will occur again. This is why crawl spaces are areas that are favorable for mold growth. It's easy for relative humidities to go up in a crawl space above 70%, even up to 90%, especially in hot, humid climates during the summertime. This is why conditioned crawl spaces have become more common nowadays, and why building science professionals have started to recommend this. The first technique is to look for visible mold growth. And one effective technique is to take your flashlight and shadow the wall like this. Things that are small, fuzzy, or difficult to see stand out when you have the light like this. You can see the imperfections in the drywall and the paint as well. Look for fuzzy, blemished, raised areas, such as this, that might be potential mold growth, and document them. The most common places for this are the drywall, because it has a paper surface on both sides, and the wood framing. Here, this is potential mold growth. A common area for moisture to be retained is between the drywall and the stud, because it doesn't get air circulation. So even though the drywall may dry quickly, this area can stay wet. One technique we use in the field is to use a mirror to look behind the walls or other surfaces. You take the mirror, hold it like this, and then shine the light on the mirror, and then move it back and forth. And you can see behind the drywall. This can also be effective behind refrigerators or appliances. And also take the light and take it like this as well. And you see up behind the surfaces. What I'm looking to do is to see the entire back surface of the drywall and the framing as well. I can also look at the space where the drywall meets the framing, the most likely area to retain moisture and have mold growth. And I can actually see up to the top of the drywall and the top sill plate. Another thing that I like to do is look up inside the wall cavity. And to do this, I put on goggles, because there is a risk that mold spores might fall into my eyes or onto my face. And if it's severely molded, I want to limit my exposure. This is a very effective technique to fully view the wall cavity. Having a full view gives you a lot better impression of the surfaces. This same technique can be applied to a crawl space, up in the attic, other framing areas, or other confined spaces.
Using our flashlight, we're going to take a look across the wall for any fuzzy growth, any water damage, or any stains, and by shining it with a real tight beam, that may help it jump out at us. And we can see here where it looks like the water level was in the house. So what we're going to do next is take a moisture meter, and we're going to see if there's elevated moisture still in the wall cavity. Okay, we're going to be using a radio frequency moisture meter, and what this does is actually detect moisture behind surfaces. It's a non-invasive moisture meter, and feeling the wall, it feels dry to the touch. What this will do is actually read behind the drywall, on the back side of the drywall, and this particular one reads about 3/4 of an inch into the wall. There's ones that do have a greater range. So the first thing we do is we come up and get what's called a baseline, and that's in like material. We're coming up high, and we can actually get a baseline. This one happens to be 170, but it shows that it's just below any elevated levels. Then we skip down the wall. You don't want to drag it because you don't want to damage the back of the unit. And we can see as soon as we get about here, we're about 4 feet up. We're in red, where our baseline now has jumped up to 850. And as we come down the wall, we can see it stays, and now it's going up, and we're at 999. So the back of this wall, we can tell, is pretty wet and at high risk for mold growth. Now we're going to use a conductive moisture meter, and we're going to take actual readings in the drywall. You don't want to do this in areas that poking holes are going to be a concern. Down here, this wall is going to be removed anyway. And pushing it in, again, I can verify that the wallboard itself is soaked. It's showing 100% here, and that's, again, a good indicator that the wall is pretty wet and at risk for mold growth. What we're going to do now is take a look at the indoor humidity levels compared to outdoor. We want to make sure that the indoor humidity levels are below 60%. Anything over 60% is at risk for water-related damage and mold growth. And we're going to use a little hygrometer to actually take a reading on that. And right now we're at 57.6, which is pretty good. And we're going to compare that to the outdoor levels. We're going to take a look at this receptacle. We can see that we have some water stains streaking down from the cover plate, and a concern, since we've had prior flooding here, is the condition of the internal components and electrical connections. So let's go ahead and remove the cover plate. And using our flashlight, we can see how severely rusted and corroded all the wiring connections are inside. So we know that this has been submerged, and it's an immediate electrical concern, and the connection should actually be cut back, new wire revealed, and a new device installed. We're taking a look in the bathroom, and what we found in here is a pretty good colony of what appears to be mold growth. And again, as we see, mold can be various colors. So this would be something that needs to be dealt with immediately.
I'm going to move into some discussion on mold abatement and issues you need to consider. First, you need to determine if it's a job too large for you to handle, and you need to protect the occupants, the workers, and follow proper protocols for the abatement. It's recommended that you hire a proper qualified mold abatement professional to do the job. What's going to be covered here are some of the more common techniques used in the mold abatement industry. One of the first things to determine is the size and density of the colonization. In other words, the mold growth or suspect mold growth. EPA defines areas of contamination as small, medium, and large. A small area is defined as total surface area of less than 10 square feet. For this, they recommend a minimum of N95 respirator, gloves and goggles, and no containment is necessary. A medium area is defined as a total square footage of between 10 and 100 square feet. For this size area, the EPA recommends that you use limited or full protection for yourself and your employees. Professional judgment is required to evaluate the size of the area and the potential exposure of yourself and employees. For this, containment would be limited. A large surface area is considered greater than 100 square feet. The potential exposure to mold for occupants and the remediator is considered significant at this level. Full protection is recommended. Full containment is recommended. You should refer to the complete EPA guidelines for full interpretation. It's a common practice when there's been flooding, such as this, to remove the drywall 2 feet above the water line, areas that have been water damaged, or areas that have suspect mold growth. There's no universal accepted guidelines for mold abatement. So what's going to be covered here is the EPA guidelines that have been published for mold remediation and abatement. They're also using heat treatments to heat the building and kill the fungi inside, or tenting the building and injecting chemicals into it to kill the fungi. The debate on that method is the fungi is still present even though you've killed it. So it is a potential allergen. It's important to understand that remediation techniques will depend on the surfaces that were wet. Materials such as block, concrete, and tile may be easily cleaned and treated. Materials such as drywall are typically removed. Wood materials such as framing may be scrubbed, cleaned, sanded, HEPA-vac, or encapsulated. Some of the common products used to clean or treat contaminated materials are fungicides, biocides, detergents, bleach, encapsulants. Depending on the area of the country you're in, the contractor you're using, the products will vary, and there's a debate in the industry as to what is most effective to use. The EPA breaks up cleanup under 4 methods. Method 1 is wet vacuuming, and steam cleaning may be appropriate for upholstery and carpeting. Method 2 is damp wiping with plain water or detergent water solutions. Scrubbing may be necessary. Method 3 is using a HEPA-rated vacuum to clean the surfaces. And HEPA stands for High Efficiency Particulate Air Filtration. And you dispose of the contents of the HEPA vacuum in a well-sealed bag. Method 4 is to discard and remove water-damaged materials in sealed plastic bags. This should all be done while in containment, if containment is present. The next concept I'd like to review is understanding personal protective equipment, PPE for short. This should be used by anybody entering the area of abatement. The minimum are N95 respirators such as this, gloves, and eye protection. Under medium contamination, we have limited protection. This would include an N95 respirator or half-face respirator with HEPA filtration, coveralls, and eye protection. A large affected area would involve full protection, full PPE. This would include head coverings, a full face respirator with HEPA filtration, coveralls, gloves, and booties, or foot coverings. If you use a disinfectant or biocide, you need to ventilate the area properly. It's important never to mix bleach with detergent solutions containing ammonia. This combination will produce toxic fumes. When using fans, you should be careful not to disturb the mold spores. Some states require that only licensed pesticide applicators apply biocides. Make sure anybody applying a biocide is properly licensed. Typically, this stud would have to be scrubbed to remove any visible mold growth. These are areas that would be HEPA vacuumed. The next area that's going to be reviewed is containment. This is using a polyethylene sheet from floor to ceiling around the affected area. Limited containment would include: it has a slit entry and covering flap. The area is maintained under negative pressure and HEPA filtered fanning. Seal off the supply and return vents in the contaminated area. Full containment would include use of 2 layers of fire retardant polyethylene sheeting with 1 airlock chamber. Maintain area under negative pressure with HEPA filter fan exhausted outside the building. And block and seal off air vents in containment area. In the event that there's been flooding and the furnishings or soft goods like clothing, upholstery have been wet. The same concerns that you have with the building materials apply to them. In the event that you have suspect conditions present, either through visible conditions or sampling, the furnishings and clothing may become contaminated. If these items are not properly cleaned, you can reintroduce spores or parts of the fungi into the building house after the remediation or cleanup has occurred. We're going into a house, according to the EPA, that has extensive surface mold growth and probable contamination in the entire structure. So our level of personal protection, PPE, has to increase. The first thing is a set of disposable full body coveralls. Next, a full face respirator with HEPA filtration. And then 2 layers of gloves that'll be sealed around the coveralls. These coveralls have a full boot that covers your shoe. What you want to remember when you purchase coveralls is to get a boot that fits your shoe that you're wearing. The other thing is you want to make sure the coveralls fit you sufficiently so that you're able to bend and move around freely and not rip the coveralls. These coveralls also have a hood for head covering. I'm going to put on the respirator next. You want to make sure that you follow proper procedures for cleaning and storage of a respirator. You can find these procedures in training manuals or at the OSHA website. It's important that you do not contaminate the respirator with used coveralls or other moldy materials. The fit of the respirator is very important. Respirators require a fit test for the person. This is again something that you want to be familiar with and learn. You need a tight seal around your face so you're not breathing in the contaminated air. The last item I'm going to put on are my gloves. In some cases, working with severe contamination or remediation, you may even want to tape your seams. The house we're now entering had a tidal surge of 2 to 4 feet and had extensive damage. The conditions we're seeing in the house now are the conditions that were found after the tidal surge. This is a result of Hurricane Wilma. This area is suspect mold colonization. It's got discoloration, water staining, irregular, patchy areas, surface. The surface is fluffy and raised. Now I'm going to take a measurement of the area. I have 13 feet on this wall. And I would say it goes up to almost 4 feet. All the walls in the house have this or greater. It's present on that wall, this wall, the wall behind me. So this meets the criteria to be over 100 square feet of possible mold colonization. We know that there's extensive mold damage throughout this house, but for demonstration purposes, we're going to go ahead and show you techniques that you can use on the investigation, or how mold can be hidden in the wall cavities or under the floor. I mentioned the walls, but look at the floor. The entire floor is buckled and raised, and it's been water damaged. I am going to use this dual mode moisture meter to test for moisture behind the walls. I have it set to